Intel announces Rialto Bridge Accelerated I and HPC processor. During the International Supercomputing Conference on May 31, 2022, in Hamburg, Germany, Jeff McVey, Vice President and General Manager of the Supercompute Group at Intel Corporation, announced Rialto Bridge, Intel's Data Center Graphics Processing Unit, GPU. Using the same architecture as the Intel Data Center GPU Ponte Vecchio and combining enhanced tiles with Intel's next process node, Rialto Bridge will offer up to 160 cores, more flops, more I/O bandwidth and higher TDP limits for significantly increased density, performance and efficiency. As we embark on the exascale era and sprint towards zetascale, the technology industry's contribution to global carbon emissions is also growing. It has been estimated that by 2030, between 3% and 7% of global energy production will be consumed by data centers, with computing infrastructure being a top driver of new electricity use, said Jeff McVey, Vice President and General Manager of the Supercompute Group at Intel Corporation. This year, Intel committed to achieve net zero greenhouse gas emissions in our global operations by 2040 and to develop more sustainable technology solutions. Keeping up with the insatiable demands for computing while creating a sustainable future is one of the biggest challenges for high-performance computing, HPC. While daunting, it is achievable if we address every part of the HPC compute stack: silicon, software, and systems. We have an aggressive HPC roadmap planned through 2024 that will deliver a diverse portfolio of heterogeneous architectures. These architectures will allow us to improve performance by orders of magnitude while reducing power demands across both general purpose and emerging workloads such as AI, encryption and analytics. The Intel Xeon processor codenamed Sapphire Rapids with high bandwidth memory, HBM, is a great example of how we are leveraging advanced packaging technologies and silicon innovations to bring substantial performance, bandwidth and power-saving improvements for HPC. With up to 64 GB of high-bandwidth HBM2E memory in the package and accelerators integrated into the CPU, we're able to unleash memory bandwidth-bound workloads while delivering significant performance improvements across key HPC use cases. When comparing third-generation Intel Xeon scalable processors to the upcoming Sapphire Rapids HBM processors, we are seeing 2 to 3 times performance increases across weather research, energy, manufacturing and physics workloads. At the keynote, ANSY's CTO Prith Banerjee also shows that Sapphire Rapids HBM delivers up to 2x performance increase on real-world workloads from ANSY's Fluent and ParseNet.